Bismillahirrahmanirrahim. Good evening, everyone. Today, our lecture will talk about the zero applied bias. Like we know, we have three kinds of applied bias. This is the first one. After that, forward and reverse bias. Let's take something like reviews. Let's come back to the important information about the PN junction diode. A PN junction diode has two terminals, P-type, P side and N side, and the depletion region will be between all of them. We have the N side because we doped it with phosphorus, belong to group number 5. That means has electrons, covalent electrons. That means 5 electrons at the last shell, because that here we can generate many of electrons here by donor one of the 5 electrons at the last shell to can reach the stable situation. The same thing with the p-type, because we doped it with the atom like boron, belong to family to group number 3. That's mean at the last shell has 3 electrons, because that will accept electron from another silicon neighbor, because that here we can generate few, not few, many of holes here. That means in one side we generated one kind of carriers. Here in inside we generated many of electrons, and in another side, the p-type, we generated many of holes. And we know the feature of the semiconductors, we can generate two of charge carriers, electron and holes. By this figure, by this diagram, I explained it. We generated two of these kinds, but lonely. In p-type, we generated holes alone, and in n-type, we generated a lot of electrons alone. Now let's come back to our notes. A PN junction diode is formed when a p-type semiconductor is fused to an n-type semiconductor, creating a potential barrier voltage. This something like the barrier voltage here, and we will be dealing with all of these at the next slides across the diode junction. Here, the effect of adding this additional energy source results in a free electron being able to cross the depletion region here and here from one side to another. Like we know, the electric field will start from electron to going to the p-type, from n-type to p-type. Why? Because at the electric field, we depend on the electric, because the main element to generate the electric field is the electrons. A PN junction diode is one of simplest semiconductor, because that not mean a lot of videos, a lot of universities take this topic, not just in the universities, but in high school and in the primary school. Take simple idea about this diode, because it's very important, and at the same time has many kinds, like I said at the this lecture, zero bias, forward bias, forward bias, and reverse bias, and how we can dealing with all of them and take some benefits from these phenomena. Current in one direction, like I said at the last slide. However, unlike a resistor, a diode doesn't behave linearly. This is very important. The question is why we can't dealing with phenomenon like that by using, for example, Ohm's law. Because here the diode doesn't behave linearly with respect to the applied voltage. as the diode has an exponential current voltage. Like we know, we have three kinds of applied biases. There are two operating regions and three possible biasing conditions. Zero bias, we will explain all of that and take the important information about this topic. And reverse bias, we explained it at the last lectures. The last one is forward bias. And here, forward bias, we will see at the next lecture how we're dealing with decreasing in the PN junction diode depletion. Here we will talk, we will explain the zero bias. What does the zero bias? That's mean no zero voltage and zero current. No external potential energy is applied, like I said before, to the PN junction when the diode terminals are shorted together. Let's explain how we can make a zero bias diode. Just take these two terminals by cables to connected all of these terminals in one point without any power, without any batteries, without any electric, AC electric. And after that, a few holes, that's mean majority, a few holes in the p-type, and like we know at the p-type, the majorities are holes at the p-type, and the p-type material with enough energy to overcome the potential barrier will move across the junction. Here, a few of majorities, that's mean holes, here, that's mean holes at the P region by overcoming with enough energy to overcome the potential barrier, will move across the barrier potential, this line, against the barrier potential. That means a few of holes in P region will try to moving by the potential barrier, try to cross this line to go to the another side, to the N region. And what this phenomenon is, what this current kind of current is, the forward current. What is the forward current? IF is the current generated because the moving of holes in the P region when it try to cross the barrier junction to reach the next side. Hole generated in the N-type material, minority carriers at the same. In the N-type, we're dealing with minority carriers. What the minority carriers in the N-type is the holes. With enough energy to overcome the potential barrier, will move across the junction against this barrier potential. That's mean here, the minority, again, we're dealing with holes. But here in N region, that's mean the holes are the minority. The minority will try by enough energy to overcome, to across this barrier potential to reach the another side. This is the reverse current. What is the difference between the reverse current and forward current? Forward current is created because the majority are the P-type. Reverse current, the current is created because the minority, but in the N-type. After that, the diffusion is created between the holes in the P-type, try to reach N side, and the minority in the N-type try to reach the P side. Because the transfer of electrons and holes back and forth across the PN junction. The potential barrier, this is very important, the potential barrier will discourage, will help both of them, the diffusion and the drift. We will know how the potential barrier discourages the diffusion of any more majority. Here, the diffusion will dealing with the majority across the junction, and the potential barrier discourages the minority carriers to drift across the junction. That's mean here the potential barrier is very important element to us, because this element will discourage the diffusion, and the drift will discourage the diffusion by dealing with the majority, try to help them to cross the junction, and will discourage the drift by dealing with minority to encourage them to cross the junction. That's it. And after that, this diagram explained to us what happened here. Here, this N-type, the electrons try to go, that's mean the majority. The N-type try to cross the barrier junction by the depletion region to can reach the whole side. And the majority at the P-type, the holes, try to cross from the depletion region to reach the N-type. And after that, what we'll do here, the depletion region is created at near from the N-type, will stay the donor ions, and near from P-type will stay the acceptor ions. And like we said before, at the depletion region, we don't have any carrier charge inside it. That means some similarity, or we can say the same situation with PN junction without connected with any power, with any battery or AC current. So that the net result is zero current flowing in the circuit when this occurs as the junction. Here we're dealing with dynamic equilibrium, but the minority carriers are continuously created. Why? Due to the thermal energy. Here we're talking about the minority. That's mean strong relation between the minority and thermal energy. So this state of equilibrium, that's mean here the minority dealing with the thermal equilibrium and dealing with equilibrium conditions. Here the equilibrium conditions can be broken. How and why? How we can stop dealing with equilibrium condition? By raising the temperature of the PN junction. Why? Because the generation of minority carriers will increase. That's mean this the only way, not only way, but this way, by using it, we can stop dealing with equilibrium condition by raising the temperature. Why? Because the minority generation of minority carrier will rising with rising of the temperature. But an electric current can't flow since no circuits. Like I said before, at the reverse bias will behave like electric circuit switch, but like a closed open circuit switch, and in some results of voltage will be at first, will be like open circuit electric at reach some volts not very high, something like 7.7 or 0.8, and that's depending on the kind of this diode. The diode will behave like open circuit electric circuit. Here that's mean and we will explain that by dealing with forward bias will behave like closed circuit or electric circuit. That's mean we will use these words to explain the diode behaviors, and not in some time, actually in many times. Here, no circuit has been connected to the PN junction, because that no way to load to the electric current to flow in this circuit. Here, let's take the summary. This normal PN junction without any connected with any power. Here with 0 bias, like I said, we will connect the two terminals from N-type and P-type like that, and take point to collect all of them. And after that, with the earth, without any power, we will dealing with depletion region. The donors ions will be near from N-type, and acceptor ions will be near from P-type. But here, I take actually all of these pictures from Google, but something is not fact, because I use this figure. I made this figure by myself, because these two figures are right, but something is not right, not fact inside this. This is the depletion region. The depletion region here, not at the center of the PN junction, will be near from P-type more than from N-type. Why? Because the majority of the mobility of the electrons at the silicon reach 1,350, but the mobility of the holes something like 450. That's mean here the mobility of electrons more than the mobility of holes, because that the P region at the normal condition will be bigger than the P-type. Like I put it here, the N region is bigger than P-type, P region, and the depletion will be at the same at between, not at the center, this PN junction, but will be always between these two types. All of these informations, that's it. This lecture is done. The next lecture we will talk about the forward bias. And thank you about your listening, your patience. I will see you at the next video. Let me pass.